Have you ever thought about what happens at the absolute end of time? I mean, the future of the universe is, well, it's absolutely amazing and honestly, a little terrifying. Welcome to today's Explainer. We're going on a scientifically grounded journey to the literal end of time. From continents tearing themselves apart right under our feet to the night sky going completely, utterly dark, we're going to miss some truly wild stuff.
But here is the biggest mystery of them all. What exactly will create the final light to ever shine in the cosmos? Just think about that. One last flash in the dark. Stick with me to the very end of our timeline today because we are going to uncover exactly what that last light will be. You definitely don't want to miss it.
All right, let's kick things off with Section 1, the near cosmic future.
So before we fast forward to the end of time, let's start with something that's been sitting perfectly still over your head your entire life. If you live in the northern hemisphere, you know Polaris. It's the fixed North Star, right? Well, actually, the stars aren't really moving. We are. Our Earth wobbles in this massive circular motion over a 26,000-year cycle. It's kind of like a spinning top slowing down. Even today, Polaris isn't perfectly north. It sits about 0.46 degrees off true north. And by the year 2400, it's going to officially leave that northern point altogether. For a while, we literally won't have a North Star, which is kind of what the southern hemisphere is dealing with right now. But fast forward about 11,700 years, and this wobble will point us toward a brand new North Star, Vega. So yeah, our sky is just constantly rearranging itself.
And you know, just as the sky is shifting, the ground beneath us is constantly changing too. Right now, deep under the Pacific Ocean, just off the coast of Hawaii's Big Island, there's an entirely new mountain growing. It's called Kamehua Kalaloa. Basically, because the Pacific Plate is moving about 8 centimeters a year, which is over a deep heat plume, islands are rising out of the ocean like a giant geologic conveyor belt. Currently, this new summit is almost a kilometer underwater. It's going to take about 100,000 years of violent, explosive growth to finally breach the surface. We're talking 10-kilometer-high columns of black ash and lightning. And to even survive up there, it has to form this hard rock armor out of cooling lava, because otherwise, the ocean would just tear it right back down into the sea within weeks.
Now, looking a little bit further out really builds our picture of the near future. Take a look at this glowing coil of dust. This is WR104. It's a binary star system about 8,400 light-years away, locked in this super-rapid 241-day orbit. For over a decade, astronomers literally called this thing a Death Star. And why? Well, because it's a rare Wolf-Rayet star that is absolutely destined to go supernova. At first, scientists thought its pole was aimed perfectly at Earth, like a cosmic sniper rifle, meaning its inevitable gamma-ray burst could completely strip away our ozone layer. Talk about a bad day, right? Thankfully, recent observations show we're actually seeing it more side-on, so the deadly gamma-ray burst will miss us, but when it explodes, sometime in the next few 100,000 years, it's going to shine brighter than Jupiter in our night sky for months. It'll be a spectacular show.
Trying to wrap your head around these massive cosmic systems can be really tough, whether you're a scientist or just someone who loves space. That's why being able to create physical models of space technology, like the James Webb Space Telescope, is so vital. Cutting-edge, super accessible tools like Bamboo Lab 3D printers let anyone bring these complex scientific concepts right into their living room. We're talking a 30-minute setup and seamless integration with the Bamboo Handy app. Plus, they have dual nozzles for multicolored filaments, making it this seamless at-home manufacturing platform. Being able to constantly update these models and physically hold what we're studying, it makes grasping these epic cosmic scales so much easier.
Moving right along to Section 2, Earth tearing and drying.
Let's shift gears and jump millions of years ahead to witness some of the massive, terrifying geological upheavals waiting for our very own planet. Right now, literally as we speak, Africa is splitting in two. It's just happening incredibly slowly, about 5 to 7 millimeters per year along the 3,000-kilometer East African Rift. So, slower than your fingernails grow. The Somali Plate is just pulling away. In places like the Danakil Depression, the ground is already 125 meters below sea level, which is lower than the Red Sea right next door. Literally, all that is holding the ocean back right now is a thin ridge of rock. In tens of millions of years, that ridge is going to crack permanently. The sea will violently flow in and, boom, a brand new ocean is born.
And while Africa tears open, up north, the exact opposite is going to happen. The Mediterranean Sea is going to completely disappear. And this isn't science fiction. It actually happened 6 million years ago when the Strait of Gibraltar sealed shut. Because it loses way more water to evaporation than rivers put back in, it dries out into this massive apocalyptic salt desert, where coastlines turn into mountain peaks. It causes a massive extinction event in the basin. Millions of years from now, it will seal up and happen all over again. But then comes the violent refill phase. When the Atlantic eventually breaks back through, water's going to rise by an absolutely staggering 10 meters a day. Ultimately, the whole basin will get crushed by tectonic forces, throwing up a brand new mountain range stretching all the way from Spain to the Himalayas. Just totally unrecognizable.
Okay, let's jump to Section 3, Solar System in Chaos.
If we jump 2 billion years into the future, we start to see how our perfectly balanced clockwork solar system is actually resting on a super perilous knife's edge. From the outside, our neighborhood looks perfectly stable, right? But if you run simulations of the next 5 billion years, around 1% of the time, Mercury's orbit dangerously synchronizes with Jupiter's. Jupiter would gently tug Mercury at the exact same spot on every single lap, stretching its orbit until it just slams right into Venus or the Sun. So why hasn't this happened yet? You can actually thank Albert Einstein for that. His theory of general relativity provides this tiny, barely measurable gravitational correction that keeps Mercury's orbit just slightly out of step with Jupiter. It's crazy to think about, but without relativity, Mercury's orbit would go unstable 60% of the time.
And speaking of incredibly tight probabilities, what about the famous collision between our Milky Way galaxy and Andromeda? You've probably heard it's a guaranteed certainty, right? Well, not so fast. Recently, scientists ran 100,000 simulations using our most modern data, and it turns out it's basically a coin flip, literally a 50-50 chance. It all depends on Andromeda's sideways drift across the sky, which sits right on that razor's edge between a hit and a miss. And the craziest part? What might actually tip the balance toward a total miss is the gentle gravitational tug of a third, much smaller galaxy called the Large Magellanic Cloud. It might just pull us slightly off the collision course.
Phew. Now, deep in the heart of our own galaxy sits Sagittarius A star, our supermassive black hole. Right now, it's asleep. It's swallowing a mere billionth of its energy capacity, basically fasting. But it won't sleep forever. 2.6 million years ago, which is right around the time our ancient ancestors were making their first stone tools, it fired out a jet so violent it blew two 25,000 light-year-tall bubbles of material right out of the galaxy. And those bubbles are still there today. One day, it's absolutely going to erupt again. And when it does, if you looked at it with an X-ray satellite, it would blaze 15,000 times brighter than the entire Crab Nebula, a total cosmic fireworks show.
Next up, Section 4, the fading dark universe. Let's fast forward 100 billion years. We're entering an era that is truly deeply haunting, a time where the cosmos becomes impossibly lonely and terrifyingly dark. The main culprit here? Dark energy. If you look at the deep universe today, there are about 2 trillion galaxies out there. But because dark energy is stretching the very fabric of space-time itself faster than the speed of light, almost every distant galaxy has already sent us its very last photon. They aren't moving away through space. Space itself is growing. So soon, they'll be receding too fast for any more of their light to ever reach us. They'll just slip over the edge of the observable universe forever.
And that leads us to a pretty horrifying reality. Around 100 billion years from now, the sky just finishes emptying out entirely. If you pointed a massive deep-field telescope into the void, you wouldn't see distant galaxies. You would get absolutely nothing, pure pitch black. But the real tragedy is that the cosmic microwave background, which is the cosmic afterglow of the Big Bang itself, will also be stretched away entirely. So any civilization living in that era will look up and only see our single isolated galaxy. They will have zero physical evidence that the Big Bang ever happened. The laws of physics will literally forbid them from ever discovering the true origins of the universe. It'll just be erased.
Finally, we arrive at Section 5, the final bang.
All right, let's accelerate to the absolute end of time. We are talking way, way in the future, long after the very last stars and black holes have completely died out. Eventually, the universe goes entirely dark. But there is one final event waiting in the shadows. It starts with a white dwarf, which is the glowing, dead core left behind by a star just like our sun. Over trillions upon trillions of years, it slowly cools down, its light fading away entirely. It becomes what we call a black dwarf, a cold, frozen, planet-sized diamond. This cooling process takes so unimaginably long that scientists are pretty sure not a single black dwarf even exists in our universe yet. We are just way too early to the party. But here's where it gets wild. Deep inside this dark, frozen lump, there's a little bit of physics magic happening.
Because the atoms inside are crushed together so incredibly tightly, they experience something called quantum tunneling fusion. Basically, slowly, piece by piece, the atoms fuse into each other without any heat at all, just immense crushing pressure. This agonizingly slow process eventually turns the entire frozen star into solid iron. And in stellar physics, iron is a massive problem. The moment enough of that core becomes iron, the dead star simply can no longer hold its own weight up.
To even wrap your head around when this happens, you have to imagine a number of unfathomable scale. 10 to the power of 1,100. That is a 1 followed by 1,100 zeros. This is exactly how many years from now the iron core of that black dwarf will collapse in on itself and violently explode. Honestly, there's no everyday analogy for a number this big. If you took the entire 13.8 billion year age of our universe and relived it once for every single atom in the entire observable universe, you would still only reach 10 to the power of 90 years. You wouldn't even be close to this explosion. It's just mind-boggling.
And that right there answers the huge mystery we started with at the beginning of today's explainer. That impossible, gravity-crushing explosion of a frozen black dwarf. That will be the very last light the universe will ever make. It will be one final flash in perfect darkness with absolutely nobody left to see it. It is, quite literally, the very last event before the end of time itself.
Which leaves us with this final, really profound thought to chew on. Are we incredibly lucky